All right, this is section 3.2, and we are going to be looking at quadratic functions. There are generally two different forms we can look at quadratic functions in. The first one, which is what you are probably used to seeing it in, is called standard form. And so we have ax squared plus bx plus c. And in order to find the vertex of our quadratic function, the shape of a quadratic function is called a parabola. It's either up or down. And in order to find that vertex, that lowest point or highest point, we use negative b over 2a to find the x value, and we plug that back into the function to find the matching y value. That is also the equation for the axis of symmetry. The vertex form, which in my opinion is a little bit more useful for graphing because it gives us the vertex in the equation. The vertex is going to be this h value and then the k value. Notice here that there's a minus sign here. So if this says x minus 3, it's actually positive 3 for your vertex. If this says plus 3, it's actually plus 3. So the sign for the k stays the same. The sign for the h will switch. If it said plus 5, it would actually be negative 5. So the sign on your h will always switch. The sign on your k will be the same. And then x equals h is the equation for the axis of symmetry. The axis of symmetry is just the line down your graph that this is symmetric across. So these are symmetric across the line of symmetry. Now, to determine whether your parabola is going up or down, if the a value is positive, this number in front, so whether you're looking at the standard form or whether you're looking at vertex form, this a value that's in front determines whether your parabola is going up or down. If it's positive, then your parabola is going up and your vertex is a minimum. If your a value is negative, your parabola is going down and your vertex is a maximum. It would be the highest value or the lowest value. For the domain and range, as we've been talking about so far in this class, the domain is all of your possible x values or your input, your independent variable, and the range is all of the possible y values, your dependent variable or your output. For most of the parabolas we will see, and definitely all of them that are in this section, your domain will be all real numbers because it's a polynomial, and polynomials are defined on all real numbers. Finding the x and y intercepts, just like we saw in chapter 2, you're plugging in 0 for y and then solving for x for your x-intercepts. For your y-intercepts, you're plugging in 0 for x and then solving for y. So for your x-intercepts, you should have a number and then 0. For your y-intercepts, you should have 0 for x and then a number for y. Words that mean the similar or same thing to x-intercepts are roots, zeros, and solutions. And let's go ahead and get into an example of graphing one of these. So this question is asking us for several pieces of information. I like to write those things off to the side to make sure I fully answer the question. So I'm looking for the vertex, the axis of symmetry, and I will abbreviate that as A of S, and you can do the same thing. We're looking for the domain, the range, the x-intercepts, the y-intercept, and whether it's a maximum or minimum, and what that value is. So we're going to start out looking for the vertex, and we're going to use that negative b over 2a that we saw above. At negative b, so in this case, b is negative 4, so negative times negative 4 over 2 times a, which is negative 2. This is positive 4 divided by negative 4, which gives me negative 1. So the x value of my vertex is negative 1. And then I can plug that into the function to find the matching y value. So plugging in negative 1 squared is 1. 1 times negative 2 is negative 2. Negative 1 times negative 4 is positive 4. And then plus 16. 4 plus 16 is 20, minus 2 is 18. So my vertex is way up there. And for my axis of symmetry, as we saw in the chart at the top of the page, it's always x is equal to the x value of your vertex. Now you always want to make sure you put that x equals sign, because without the x there, it's just a number, but the axis of symmetry is actually an equation. It's a line. So you do need to write x equals -1. Do not just write -1. I'm going to go ahead and start actually setting up my graph. I know that my parabola is going down since my a value is negative. And I'm going to draw my graph so I have a lot of space up top because my vertex is way up at -118. And on the x-axis, I'm still going to count by ones. And on the y-axis, I'm going to count by twos. So if you're ever counting by something besides 1, you need to label what you're counting by. So -1, 2, 4, 6, 8, 10, 12, 14, 16, 18. Oops, I lost my place there. 1, 2, 3, 4, 5, 6, 7, 8, 9. And there is my vertex. I can also find my y-intercept fairly easily by plugging in 0 for x, 0, 0, 16. So that would be here. And I know that parabolas are symmetric across this line, the axis of symmetry here. So I can plot the same point on the other side. So however far over I went here, I would go over the same distance in the other direction. And that gives me 2 points. I actually know what my graph looks like at this point, but I'm going to wait to plot it. As I said previously, the domain for all polynomials is -infinity to positive infinity. This is a polynomial, so my domain is -infinity to positive infinity. Now my vertex also tells me my max or min value. It's always the y value of your vertex. Determining if it's a maximum or minimum is if your parabola is going up or down. Because my parabola is going down, that vertex is a maximum. So I only have 2 pieces left here, the x-intercepts and the range. I'm going to go ahead and find my x-intercepts, and we find those by setting our equation equal to 0. Change that to a 4. X plus 16 equals 0. So pulling out a -2, I'm left with x squared plus 2x minus 8 equals 0. I can use the x method to factor that real quick. -8 and 2, I have 4 and -2. Multiply to -8 and add to +2. So -2 times x plus 4 and x minus 2 equals 0. X equals -4 and x equals +2. So those are my x-intercepts, but they need to be written as a coordinate. So -4, 0, and 2, 0 are my x-intercepts. I can go ahead and plot those points now. And those line up with my graph. I can go ahead and draw my graph now. And that's what it should look like. So my last question to answer is the range here. So my range is going to be my y values from least to greatest. So if I'm going from least, my lowest y values, well, my parabola is going down forever and ever and ever. So I'm coming from -infinity, and then I have all the y values until I get to 18. And that's the last y value. There's no y values up here. So it goes from -infinity to 18, and I'm going to put a bracket on 18 because it does actually equal 18. We have a point there equaling 18. And that is how we would graph and answer all of those pieces of information for this example. All right, so let's go ahead and flip the page and do an example now in vertex form, answering the same pieces of information. And so that I don't forget anything, I am going to write them down again. So I'm looking for the vertex, the axis of symmetry, the domain, the range, the x-intercepts, y-intercept, and the max or min. So I can find these pieces of information very similarly to the last one we did. The nice thing is this is in vertex form, so I have my h and my k right in my equation. Remember, it's the opposite sign for the h, so my vertex is -3, 2. That means my axis of symmetry is x equals -3. That means my max or minimum value is 2, and because my a value is positive, I know my parabola is going up. That means this is a minimum value. We said that the domain for all of these is negative infinity to positive infinity because they are all polynomials. And we only have 3 pieces left to answer. I'm going to go ahead and start setting up my graph. I have -3, 2, and my parabola is going up from there. So -3, 2. And I'm going to go ahead and find my y-intercept now. I'm still plugging in 0 for x. 0 plus 3 is 3. 3 squared is 9. 9 times 2 is 18. Plus 2 is 20. And I'm wishing I had adjusted my x-axis a little bit here, but that's okay. I'm going to, again, count by 2's on the y-axis and 1's on the x-axis. And so going up to 20, I'm at 2, 4, 6, 8, 10, 12, 14, 16, 18, 20. And that's over 3. I can go over 3 and up to the same point on the other side. And that's actually enough for me to draw my graph. Not a very good curve there, but that's okay. And even from my graph, I can see my graph does not even touch the x-axis. It never touches. If my vertex is above the x-axis and my parabola is going up, or if my vertex is below the x-axis and my graph is going down, I have no x-intercepts. So there's nothing for me to solve for there. I can go ahead and answer my range, and thinking from least to greatest, my very first y value is at 4. It does equal 4. Oh, you know what? I plotted this here and then counted by 2's. This should actually be down a little bit lower here. Let me have and fix that. Hopefully I can fix the curve of my graph a little bit here now. All right, it's looked better than that before, but that is what it is. So my range is actually, again, I knew that from my vertex here being at 2, is 2. And so this is -3, 2. So my range is from 2 all the way up to infinity. Okay. All right, so that is graphing quadratic functions. What we are going to shift to now is solving quadratic equations. And we already have the X method and some other tools you might have seen, completing the square, things like that. We're going to add to that the quadratic formula. And this is the quadratic formula right here. You need to know that. I won't ever give that to you. You need to make sure you know the quadratic formula. And if we are given a quadratic equation of this form here, I can use this to find my roots or my zeros or my solutions. So looking at this first example, it is not set equal to 0. So the first thing I need to do is get that 3 onto the other side. I can add 3 to both sides, and I have 2x squared plus 5x plus 3 equals 0. My a value is 2, my b value is 5, and my c value is 3. And I can find my x values by plugging those into the quadratic formula. So negative b would be -5 plus or minus the square root of 5 squared minus 4 times my a value, which is 2, times my c value, which is 3, all over 2 times a. Simplifying that, I have -5 plus or minus the square root of, and this is 25. And 4 times 2 is 8, times 3 is 24. So 25 minus 24 is just 1. So -5 plus or minus, and the square root of 1 is 1 over 4. I can actually find my two x values. -5 plus 1 is -4. -4 divided by 4 is -1. -5 minus 1 is -6. -6 over 4 reduces to -3 over 2. And those are my two solutions. In the next example, We have 2x squared minus x plus 5, and we can go ahead and solve. I have a is equal to, b is equal to, c is equal to, a is equal to 2, b is equal to -1, and c is equal to 5. X is equal to, plugging in that b value, negative b would be a positive 1, and then -1 squared minus 4 times a times c, all over 2 times a. And inside my square root here, I have 1 minus 4 times 2 is 8 times 5 is 40. So 1 minus 40 is -39 over 4. I can rewrite that as 1 plus or minus I root 39 over 4, and that would be my answer. Those are my x values. There's nothing else I can do to simplify that one. I don't know the square root of 39, and there's nothing I can pull out of that, so I would leave it just like that. For the next one, I need to get it set equal to 0, so I'm going to subtract 2x and add 10 to both sides, and I get x squared plus 2x minus 10 is equal to 0, or plus 10 rather, and minus 2x. Needed to subtract those over. And so my a value is 1, my b value is -2, and my c value is 10. And so x is equal to negative times -2 would be +2. -2 squared minus 4 times a times c, all over 2 times a. 2 plus or minus, and here I have 4 minus 40 is -36 over 2. Well, we actually did this at the top of the page on the section 1, where we simplified the square root of -36. That is 6i, so I have 2 plus or minus 6i over 2. 2 over 2 plus 6i over 2 simplifies to 1 plus 3i, or plus or minus 3i. And those would be my two solutions. Now for this next example, I need to multiply out those two factors before I can even start using the quadratic formula. I need to get this set equal to 0. So if I do the box method here, I will end up, or FOIL, with x squared minus 5x plus 6. And if I subtract x squared from both sides and I add 5x to both sides and subtract 6, I end up with x squared plus 5x minus 6 equals 0. And I can go ahead, actually, I'm not going to use the x method, but I will tell you that we could use that here. I'm going to practice using the quadratic formula though. So my a value is 1, my b value is 5, and my c value is -6. So x is equal to -5 plus or minus 5 squared minus 4 times 1 times -6, all over 2 times 1. That's -5 plus or minus, and that's 25 plus 24, and that makes 49 over 2. -5 plus or minus 7 over 2. Well, -5 plus 7 would be 2. 2 divided by 2 is 1. And -5 minus 7 is -12. -12 divided by 2 is -6. Now we use the quadratic formula, but I will show you real quick that we could have used the x method from this point here. So if I use the x method there, I have -6 up top and 5 on the bottom, and +6 and -1 multiply to -6 and add to 5. That would be x plus 6 and x minus 1 equals 0. And setting those equal to 0, we get -6 and 1, which is what we got using the quadratic formula as well. Okay. We have another one on the next page. We have 4x squared equals 4x minus 1. We need to get that set equal to 0, so that would give us 4x squared minus 4x plus 1 equals 0. A equals 4, B equals -4, and C equals 1. So x is equal to negative times negative 4 would be positive 4 plus or minus negative 4 squared minus 4 times a times c all over 2a. And we end up here with 16 minus 16, which is 0. And the square root of 0 is 0. So 4 plus 0, or 4 minus 0, is still just 4. So I have 4 over 8, which is 1/2. That means I only have one solution. That means my vertex is on the x-axis. I only have one spot where it touches the x-axis. All right, so in these next couple examples, we have our vertex and a point. And you know what? These examples are going to take a little bit longer. I think it's probably best to end this video here, and I will do these last few examples in a part 2 video. So you can finish up this section in that video.